Hi, my name is Justine Harkness, and in this video we'll learn how to predict the products of syn addition. An addition reaction is defined as adding to a pi bond. So we can add to double bonds, we can add to triple bonds, but we will not see addition reactions with single or sigma bonds. Now, one type of addition reaction is a syn addition. Think syn for same. Syn for same. During syn addition, we add the groups to the same side of the pi bond. And during addition reactions, we can observe a few different things. So let's look at an example of we're going to start with an alkyne, and we're going to add via a syn addition pathway. So we'll see our two substituents will be added to the same side of that double bond. Now we're going to look first at the bond order being defined as the number of bonds that you have between your two atoms. So in our alkyne, our bond order would be 3 since we have 3 bonds connecting our 2 carbons. After that addition, we now have one less bond between our 2 carbons. We only have 2 bonds now, so our bond order would be 2. So during an addition reaction, we will see a decrease in that bond order. Now, if we look at how the number of substituents change, notice before we had implied hydrogens here. They're still there after the reaction. But we go from having 1 substituent on each carbon to now having 2 substituents on each carbon. So during addition reactions, we'll always see an increase in the number of substituents. So let's take a look at a few examples of organic chemistry reactions that you may have seen or will definitely see during your organic chemistry class. So in our first example, we have cold potassium permanganate is an oxidizing reagent that oxidizes an alkene to an alkane through the syn addition of 2 hydroxyl groups. We want to know what the product of this reaction will be. Now, during an oxidation reaction, this is where we add bonds to oxygen. So since we are adding 2 hydroxyl groups, we'll be attaching oxygens. These would be oxidizing reactions. Now, during this addition reaction, we will not change any of the connectivity between our atoms. All of our sigma bonds will remain the same. However, we will be breaking this pi bond to make room for our OH groups. So we can draw out the carbon backbones of our products. This is all of the sigma bonds that we had in our original starting substrate. Now, there are 2 different ways that we could add these OH groups. We could add them so that they add above the ring, or we could add them so that they add below the plane of the ring. And we call these 2 different types of products stereoisomers. And this is something we will be covering in a later video. These are 2 molecules that differ in the arrangement of the atoms in space. We have all of the same bonds. Now let's take a look at another example, and this is honestly one of my favorite mechanisms. This is because it's really, really cool how it works. So here we have alkynes can be reduced to cis-alkenes through the addition of 2 hydrogens using Lindlar's catalyst. So this would be an example of a hydrogenation reaction since we will be adding hydrogens to our triple bond. So let's take a look at how Lindlar's catalyst works. So Lindlar's catalyst is essentially a chunk of palladium, and the hydrogens will stick up from it. So when we have our reactant, it's going to come in and dock, and notice that the hydrogens are aligned to be adding on the same side of that triple bond. So for that reason, after we transfer those hydrogens to the triple bond, they add to the same side and we get a syn addition to form a cis-alkene. You should now feel comfortable predicting the products of syn addition reactions.